Welcome everyone to Week 1, Lesson 2, focusing on location, found within our first section, Understanding the World in Spatial Terms. This is Ms. Taggart, and let's get started. In geography, it helps to understand that location can be described in two ways, absolute terms or relative terms. Absolute location is the exact spot on Earth where something exists. This is where you can get your degree, and it can be found directly on a GPS. Relative location is a general position of where something is in relation to other things. For example, the United States can be described as being south of Canada and north of Mexico. Knowing the relative location of a place can help shed light on the characteristics of that place. Now let's get a little bit more specific. The prime meridian is the line that is running from the North Pole to the South Pole. The equator is breaking the globe into two hemispheres. The equator is the yellow line directly across the middle. Everything found north of the yellow line is the northern hemisphere. Everything found south is the southern hemisphere. The vertical line called the prime meridian runs from the North Pole to the South Pole and divides the Earth into east and west halves. Now let's get a little more specific with latitude and longitude. The prime meridian and the equator are just the two central lines that circle the globe. There are additional imaginary lines, like the equator, run east to west. These are called latitude lines. They are also known as parallels because they run parallel to the equator. All latitude lines north of the equator are called north latitude lines. All those found south of the equator are labeled south latitude lines. Latitude lines are labeled with degree symbols, which indicate how far the lines are from the equator. They are also labeled with the letters north and south to indicate whether they are north or south of the equator. The equator itself is found at 0 latitude. In addition to latitude lines, geographers use another set of lines called longitude. These imaginary lines run north and south across the Earth, always crossing the North and South Pole. The 0 degree line for longitude is the prime meridian. All longitude lines east of the prime meridian are called east longitude lines. All longitude lines west of the prime meridian are called west longitude lines. Similar to latitude lines, longitude lines have degree designations and the labels E and W to measure how far east or west the lines are from the prime meridian. By seeing where latitude and longitude lines intersect, geographers can find the absolute location of places on Earth. Understanding latitude and longitude makes understanding maps and keys much easier. Maps are the flat drawings that show the features of an area, and they are essential tools for geographers. However, there are many different kinds of maps. Some maps show natural features, physical features like mountains, lakes, oceans, and continents. A continent, of course, is a huge landmass. There are 7 continents in the world: Asia, Africa, North America, South America, Europe, Australia, and Antarctica. Maps can also show other kinds of information, including political boundaries, population, roads, rainfall, votes that are cast in an election. However, a good map will generally include 3 basic elements to help readers use it properly: a compass rose, a key or a legend, and a scale. The example of the map you're seeing before you is understanding the picture and understanding how the key helps you use the map. A scale is typically the measurement listed at the bottom to show miles or kilometers. I'm often asked this question: why do maps look different? Because there's many different kinds of maps. Let's take a look at the 3 that we're going to focus on. A cylindrical map. What would the Earth look like if the North and South poles were pulled apart so that the Earth looked like a cylindrical can rather than a ball? This is how this particular projection works, by turning the Earth into a flat rectangular map. Within the three maps that we're looking at, each has a positive and negative and how it distorts the way a globe shows the actual projection. This one in particular shows true direction on the globe, meaning that you can clearly see what is found east and west, north and south. It shows the true shapes of bodies of water and land, and however, it does make areas near the poles appear much larger than they really are. It makes areas near the equator appear much smaller. So it's going to this particular map does not show accurate distortion. Now let's take a look at the next. A conical map. This is a conical projection. It shows part of the Earth's surface on a cone shape with the point of the cone over either the North or South Pole. It is often used to show large areas going east and west. And it's often used when creating regional and national maps. The positive of this map is it has little distortion except for the areas near the edges of the map. However, it cannot depict the entire surface of the Earth, just the areas closest to either the North or South Pole. Another form of a map projection is called a flat plane projection. This type of a projection is shaped like a flat round coin, and its center corresponds to one spot on Earth, usually the North or South Pole. This map accurately shows the direction from a central point such as the North Pole. It's useful for helping airline pilots navigate. It shows direction and areas accurately, however, only in relation to the central point. And it cannot depict all of Earth, but only part of it. However, many of us today do not use a typical map. We're all about using graphic technology, which has moved far beyond what it was in the early days of sea travel. If you compare modern maps with those drawn hundreds of years ago, you'll see far more detail and accuracy nowadays. This is because geographers have made huge improvements in the tools they're using to gather and analyze this information. One of the oldest and most basic geographic tools is a compass. A compass has a magnetic needle that always points true north. If someone knows which way north lies, he or she can tell the correct direction for south, east, and west. A compass is thus useful for navigating on land or water. Another tool is this found here. You may have never seen one before. It's called a sextant. This particular tool helps you calculate latitude and longitude. However, the one we're most familiar with, and is often can be the most accurate, is GPS, which is a global positioning system to navigate over land or water. A GPS receiver takes in radio signals from space satellites and uses these signals to calculate the location of the GPS user. The GPS receivers can be placed into any vehicle, ships, airplanes, cars, or people walking by foot. These devices can even tell the time of day and give directions aloud, as many of us know when using them in our car. However, you always have to watch, because oftentimes that area they want you to turn right isn't right there. So let's take a look at how we're going to finish week 1 in lesson 2. Within week 1, lesson 1, you were assigned the discussion board. At this point, you need to make sure you've responded to your peers, as well as your instructor. You need to complete week 1 homework assignment 2, and you need to take a look at your weekly project. This project is going to be due on Friday by no later than 9 p.m. When completing your weekly project, you need to make sure that you are looking at the rubric so you address each part of the project. And remember, if you come up with any questions or any confusion whatsoever, please contact me or your peers using the discussion board. I look forward to hearing your questions and to continue reading your responses within the discussion board.